as I mentioned in the previous video, you can do for loops to iterate over something multiple times, an arbitrary number of times, however many times you want. You can also stick loops inside of loops, right? So they become like nested multi-dimensional things. And this becomes really useful when you're working with images or video pixels, that operate on, two dimensions. In 3D stuff, you can start to think about it as in multiple dimensions, right? So for this, what I'm going to do is I'm going to show you how you can use nested for loops, and you can do that to create patterns. You can do that to create things that repeat over time. And I'm going to start out with a basic example, and then I'm just going to like get a little weird with it. And so, if you're feeling a little bit at the end, that's okay. I'm more interested that you understand the first part of what I'm going to be talking about here more than anything else. So we already know what a for loop looks like, right? We've got, for, and then we'll say let x equal 0. X is, we'll draw circles on the screen again, right? And so we'll say x is less than width, x plus equal 50, right? And then we can say ellipse, and then the center of this will be, at x, and y will say height divided by 2, and then each one of these will be, I'll say, 25 is for its size, right? So here now we've got a whole bunch of circles. Cool. So what we can do here now is we've got this x that like iterates across, right? But if we wanted to, we could stick another for loop inside of here that operates for the y, right? So we could say for let y equal 0, y is less than height, y, we'll keep it at 50, plus equal 50. And then we can create some new braces here, right? Brace there, a brace there. We'll clean this up so we get some nice formatting. And instead of saying height divided by 2, what we can do is we can stick y in there, save it, and then, oh, look at that. We've got like all these circles now. This is so exciting. One of the things that we can do too, we can see how it sort of like overlaps right here. We can offset this too, right? So we could say plus 25, plus 25, and let's make this 50, right? There we go. There, so now we've got like this whole dense thing packed full of circles. Pretty cool, right? So what we're doing here is we're saying, for every time we go through x, then loop through y, right? So first we like do this, and then we go through all these, and we go here, and we go through all these, then we go through here, and we go through all these, et cetera, et cetera, et cetera. So this now gives us the opportunity to make many things happen over time, right? And we can start to introduce some variance in here, and we can start to do some like more interesting things. So we've got there's this function called noise, and noise is different than random. Random is like a completely random number. It's just, it's actually a mathematical equation. It's not truly random in a computer, but it's close, right? It seems like just white noise. So, and that's fine if you're looking to just generate a unique seed for something, but oftentimes we don't really experience randomness in nature that often. Instead, we see like changes in patterns that shifts slightly and subtly over time. And that's where there's this function called noise that comes into play. And it's based off of a mathematical principle by this guy, Ken Perlin, who he won an Academy Award for it, for coming up with this algorithm. He created it for the movie Tron back in 1982 so that it generated textures on materials that seemed natural and not, super computer slick. Which is funny since it took place inside of a computer. But in any case, the way that noise works is you feed it a value, and then it'll spit out a number, and then you feed it another value that is slightly incremented or decremented from that first one. It'll give you another number that's like off base from that, right? So we can see this here. What I'm going to do is what it'll give us is like a floating point number, right? No matter what you feed it. So what I can do here is I can say let size equal noise, right? And we want noise to be well, actually, first let's do it like this. Let's do it so it stops and just runs once, right? And so we'll say x. What do we want to do here? We'll do x plus y divided by 1,000, right? Because we want small numbers for this, right? So x plus y divided by 1,000, and then what we'll do here is we'll multiply this by 50, right? And then we can replace size here, and you can see there's a little bit of variance, not a whole lot. Make this, there we go. There, so now we can see there's a whole bunch of variance now in these, and it's following like a pattern, right? It's not totally random. We can see bands of different things happening in here, visually kind of appealing. Now, if we were to like get rid of this, we'd actually see the same thing all over again. What we want to do is, I just threw that in there as like a safety measure. What we can do actually is, instead of, because this is like a fixed value, right? It's not changing over time. But if we had something in here that was changing just a tiny bit every time, right? We'll call this increment. So increment will start out at 0. And every time we go through our loop, we'll add a little bit to that, right? So we can say increment plus equals 0.001, right? And so now we can say size equals noise, and we'll just say increment. And this is probably coming out too small to be useful to us. So instead, what I'm going to do is I'm going to say x plus y times width, which is going to be, just so you can see what this looks like here, this is going to be, there we go. So this is going to now sort of move the noise along this axis here, right? If we were to increase this now we'd see, yeah. So you can see a little bit more clearly along how these bands here. You'll also realize that in some ways I'm just sort of like, this is all very fungible, right? Sort of like mushiness here. What I'm going to do is I'm going to take this value right here, and then I'm going to add that this value of increment. So I think what I was doing before was just too small for it, right? And I've run into an error. What is the error here? Oh, that's what it is. There we go. Now if I do that, oh, look at this. Now we can see it's slowly changing over time, right? Now we've got these sort of like pulsing things. Kind of like breathing, right? So this is a one way that you can start to use these things, right? And if we wanted to just sort of like freestyle this a little bit, we could also do this with, we could also incorporate color in here, right? So we could do something like this where we said color mode, HSB, so we're going to be using hue, saturation, brightness as opposed to RGB, right? And then here what we can do, we can change, we'll make the stroke a little bit heavier, stroke weight, and we'll give that 5, no fill, no fill, right? And then in here, what we'll do is we'll set the stroke color, right, to be, so the way that HSB works is it's like a color wheel, right? So it's 360 degrees. So we can say 360 times, and so this is the hue, and the hue goes around in a circle. So we can say the hue is going to be, X divided by width. And then the brightness will be, which is on a scale of 100, we'll say, the saturation, which is on a scale of 100, where 100 is totally saturated and 0 is desaturated, right? So we'll say that is Y divided by height. And then we'll just, the brightness we'll put at, 100. So it's like totally bright. And then if we save this, we'll get some really nice colors like this, right? So now we've got something that is changing color dynamically. It's changing size dynamically. Well, the color's not changing dynamically, but we've got a lot of color in there. We're changing the size. We're doing a whole bunch of like really like kind of fun things here. So this is just to say that there are, just a couple lines of code here. You can start to get something like kind of very appealing. I'm going to put some stops in here, but you could push this a little bit further, where these are all sort of like you could say size times 2, so that these things start to overlap with one another. You can change the color so that there's opacity, right? We'll make this stroke maybe a little bit fatter. There we go. And then we'll do this other thing too, where I'm going to get rid of the background. And if I did that completely and I just ran it again, you see how like it's not erasing the background, so everything just sort of like draws over itself. It's a neat little trick, right? But we can make it so that we get sort of like trails too. So if we draw a rectangle across the entire space, so I'm going to do this. I'm going to first say no stroke. No stroke, right? Fill is going to be, this is where I'm going to set the color and the opacity. So I'm going to say the color really doesn't matter. So we're going to say red, 0 in HSB is red. The saturation is going to be 0 and the brightness is going to be 100. So that means that it's white. And then the opacity, I'll put it like 10%. And then what I'm going to do is I'm going to take this rectangle here, the rect, right? And I'm going to say it's going to be 0, 0 with height. And so now when I do this, we should see we should be getting these kind of like, it's really subtle. I'll make these a little bit more noticeable. I'll make this 0.5. These things are leaving behind really subtle trails now, right? So if I make this even less, it'll be even weirder, right? So you can see now as these things sort of like breathe and move, they're leaving behind really subtle little bits of color that slowly fade away, right? So, this is just a way of sort of saying that, like, you can do a lot of quick iterations with things just by changing a few small values in your code. Try experimenting with color modes, try experimenting with, like, for loops, using noise or randomness, these are all just different ways that you can kind of, like, play around with this stuff and get some quick and impressive results without too much work.